So welcome to the first session of CS254. The class is a class on concurrent object-oriented programming. And what I'm going to do is start out by giving you an overview of what we'll be covering this semester. So the motivation for this class is the growing need for programmers to learn how to take effective use of multi-core processors. And this includes devices ranging from things like smartphones, like my Android phone, which has 4 cores, my laptop, which has 8 cores, desktops, which typically have 4 to 8 cores, servers, which can have more than 8 cores, and so on and so forth. And so there's a big motivation to be able to take advantage of all this parallel processing. And we're going to be focusing on Android here in the class as the environment to do the development, but the topics are much more general than that. So everything we're going to cover applies to other environments, not just Android. We just use that because it's a fun form factor, and it's something that gives you an interesting application that you could literally hold in the palm of your hand. These advances are driven by a lot of different factors, the need for concurrent programming. Of course, the fact that you have lots of cores is part of it. And why do you have so many cores? The reason we have so many cores nowadays is because transistors, the number of transistors on a chip continue to grow, but getting the chips to run faster has kind of petered out at around 3 to 4 gigahertz per core. And so what people do now is, instead of expecting their programs to get faster by doubling the performance every 18 to 24 months, which is what's known as Moore's Law, instead they use all those extra transistors to make multi-core processors. And there's other things that are motivating this too. Obviously, storage has gotten a lot bigger. Networks have gotten more ubiquitous. The performance and the speed of networks has gone way up. There's commodity hardware and software platforms that have multi-threading baked in, like Windows or Linux or Java, as we're going to talk about here, or Android for that matter. So there's lots of opportunities to take advantage of all these features. Concurrency, we'll talk more about what concurrency is in a minute, but at a high level, concurrency is a method of offloading work from user interface thread, the user interface thread, because there's typically only one of them, to background threads in various contexts. User interfaces on laptops or desktops would be one example. User interfaces that you'd find on your mobile devices like iPhone or Android are also examples of this as well. We're going to see that it's important to not just get concepts. We're obviously going to talk about a lot of concepts in the course, and you get a good conceptual understanding of what we cover. But it's also important to have a deep understanding of how to make this stuff really work. You have to do more than just think, you have to do. So a lot of this class is going to involve the doing part, which is basically developing applications using the concepts that we're talking about. And so we're going to be focusing on techniques to make it easier to read and write concurrent software, easier to maintain and modify concurrent software, easier to make the concurrent software that you write and read more efficient, more resilient, and so on, by applying time-proven software patterns and object-oriented and/or functional design and programming techniques. So we'll talk about objects, that's a big focus, but I'll be throwing in a smattering of functional programming, especially in the context of lambda expressions and method references. And we'll talk a bit more about that, and I'll show you where you can learn more about that. So a lot of this class focuses on developing software and then testing it using various sophisticated white box testing frameworks. So what are we going to be covering here? We're going to start with a focus on foundational Java concurrency mechanisms. And this will include both the threading mechanisms that are in Java, and you'll get exposed to that starting with assignment number 1 here. And there's also a bunch of so-called synchronizer mechanisms, and you'll get exposed to those. So the assignments that we'll do, which we'll talk about more in a second, are going to kind of go back and forth between learning some new threading mechanisms, getting a chance to implement those. That's part A of all the assignments. And then part B, we'll have you do some stuff with synchronizers, and they'll build on each other as we go through the different assignments in the course. And I'll talk more about how many assignments there'll be in a short time as well. As you can see, we have roughly about the same amount of coverage on threading mechanisms like threads and the executor framework and thread pools and so on, as we do on synchronizer mechanisms, which includes things like synchronized methods and statements, various kinds of locks, reentrant read-write locks, stamped locks, various kinds of coordination mechanisms like condition objects and semaphores, as well as barrier synchronizers like countdown latches and cyclic barriers and so on. And you'll see that these are used together. So it's very rare when doing concurrent programming to only worry about threading. You typically also have to worry about synchronization. And you'll see more about that as we get further along. We'll also be covering a whole bunch of patterns and frameworks for concurrent programming, A framework is a set of components that work together to provide a reasonable architecture for a family of related applications. I'll talk a lot more about frameworks later. And patterns are basically little microarchitectures that help capture solutions to common problems that arise when you build software in a particular context. Hopefully you've taken the Intermediate Software Design course, CS 251, here at Vanderbilt, or something equivalent, where you've learned about patterns. You'll get exposed to other patterns. Some of the ones you'll be familiar with, some of the ones you won't be. But we'll talk about those a lot because it helps to do a better job of writing concurrent programs. I'm assuming that you either know or can quickly learn Android, and you don't have to know that much about Android. Android Studio, you do have to know enough about Android Studio to get your projects loaded and run and debugged. Modern Java, and this really focuses largely on things like the functional interfaces, lambda expressions, method references. And if you take a look at item number 12 in the frequently asked questions file for the course wiki, you'll learn about the ways to get more information about this stuff if you don't know much about it yet. And Git. So hopefully you've had some exposure to Git in intermediate software design. Hopefully that's what we're going to be using for source code control, and more particularly for me to be able to see what it is you're doing and give you comments on your code. You'll see that there are three main topics in the course, which I alluded to earlier. There's the threading mechanisms, which include Java threads and runnables, which we're going to start shortly towards the end of this class, and the Java executor framework. Those are the main things that deal with threading, and there's quite a bit of that, so that'll cover roughly 6 or 7 weeks in the course. And then we're going to talk about Java synchronization and Java synchronizers. And this will include the built-in monitor object features that have been around since day one in Java and before, when Java was an oak, which was a language developed by James Gosling at Sun before it became Java. And we'll also talk about all these gazillions of synchronizer classes in the Java util concurrent package. So those will be the focal points for that. And as I mentioned before, we'll talk about some patterns as well. We're going to bounce back and forth between these topics in order to facilitate the assignments. So we'll cover a little threading, a little synchronization, then some more threading, then some more synchronization, and so on and so forth over time. Each topic we're going to cover is composed of a bunch of lessons. Each lesson is composed of parts. Each part is a single lecture. And I will go ahead and upload the parts to my YouTube channel, and I'll make them available here at my website. And each part will have a lesson, and they'll also have the PDF version of the slides that we use to cover that stuff. And that's so you can go back and rewatch it if you need to. If it's hard to understand me talking through a mask, maybe it'll be easier to understand it if you listen to the recording. Okay, there'll be periodic tests, or more specifically quizzes, that are going to be covered throughout the semester. All the tests, including the final, if we have one, we'll talk about that momentarily, are closed. Closed book, closed internet, closed electronics, open mind, but everything else is closed. And the first quiz will be next Wednesday. So that quiz will cover everything we talked about today and Monday, but not what we cover on Wednesday, of course, because you wouldn't have a chance to learn that yet, conceivably. I will do my best with help from graders to grade and review the quizzes by the next class, which is one of the reasons why we don't have 70 people in the class. We have more like 35 or so, 40 maybe. So this should give you good feedback. And the people who are TAing the class have taken the class, so they're very familiar with the material, which is good. The best way to study for these quizzes is by reviewing the slides and watching the screencast lectures that I upload to this link. And I will, of course, put this link up as well, so you'll be able to get to that. Now, very important. I will emphasize this multiple times, and I will enforce it much more strictly than I've done in the past. So we are having face-to-face classes for a reason, because Vanderbilt believes that that's how people learn best. And even though I record the material, that's not a substitute for coming to class. So you have to come to class. If you don't come to class, you will get penalized in all kinds of different ways, and you'll learn more about that. So make sure you show up in class, make sure you participate. We'll talk more about that too. There may be a final exam, maybe. It all depends on how things go with the programming assignments. So sometimes we have programming assignments that are a little longer, and so they kind of spill over into exam time. So what we do in that case is we don't have an exam. You just finish up your programming assignment in the time slot that would have been your exam. If we get done with the programming assignments and don't have it bleed into reading week or final exam week, then we'll have a final. And if we do have a final, according to the schedule I looked up, the revised schedule, it's from noon to 3 p.m. Monday, and we'll either do it here or via Brightspace. I haven't quite figured it out yet. There's pros and cons with each of those things. There will be programming assignments written using modern Java. That should actually say Java 11, because that's the new version that's available with the modern version of Android Studio, the latest version of Android Studio. So you'll be using Java 11 in Android Studio. And you need to use the API level 30 version of Android and the latest version of Android Studio. I'll talk more about where to find those things in a second. Again, Java comes pre-installed with Android, so you're fine. You don't have to do anything special. Back in the day, you used to have to install Java separately, but now it just comes pre-bundled, which is nice. We'll be doing the development with Android Studio. You may or may not have used it before. It's a plugin that's loosely based on the IntelliJ IDE from JetBrains, and it's pretty nice. It's got a few little quirks here and there, but it works fairly well. We're not going to use all the advanced features because we're not really writing the GUI. The GUI for the app that you're using will be given to you. You'll be working on the concurrency stuff. But there's some neat stuff in here that you should get used to using, including an emulator and a debugger, which is important to try to figure out what's going wrong, because things will inevitably go wrong. Here's the version of Android Studio that you need, version 11. Anybody here who's ever seen the classic mockumentary, This is Spinal Tap, will understand the image that they used for Android 11, which is basically a knob that goes to 11. And all the source code will be available in my GitHub repository. This is where my GitHub repository is for this class. And if you go there, you can clone the repository by clicking on this button, and it'll give you the Git ID or the URI for the class, for the repo, and you can go ahead and clone that. I'll talk more about that in a second. If you don't already know how to use Git and GitLab and GitHub, you'll need to learn how to use those things. That's also described here in the FAQ. There's actually a number of things to help you with that. If you have experience with this, it shouldn't be a problem. Inevitably, people will have some problems because it can be a little tricky at first if you've never used it before. But luckily, the TAs, the graders who will have office hours, will provide you with what you need to get started. You may or may not need to update your repository. I've gotten better over the years at releasing the assignments with everything working correctly when they go out. Every once in a while, there'll be a bug or something that creeps in. So you'll need to understand how to pull from my repository, and that can be a little bit confusing at first too, but there's a FAQ that explains how that works. So you should retake a look at that. The assignments are going to give you a range of experience with modern Java on the Android platform. And again, Android is pretty much modern Java. It doesn't have the latest, greatest stuff, but that doesn't matter because the things that we're using don't need the latest, greatest version of Java. Java 11 is perfectly fine. In particular, you'll be implementing different variants of a concurrent resource manager, and I'll talk more about what that means in a second, that runs in the context of an Android app. And here's just a screenshot of the app in motion, in action. And basically what you have here is you have a bunch of Palantiri, which is something from Lord of the Rings, and different beings from Middle-earth, like wizards and hobbits and other elves and so on. And these different beings take turns gazing into the Palantiri. And so it's a classic concurrent resource management problem where you've got M resources, which in this case is Palantiri, and you have N users, clients, beings, threads that want to be able to gaze into those things. So they have to take turns basically sharing access to the resources concurrently. So it's a really great example of a problem you run into all the time when you're building concurrent applications, especially with servers. So we'll be looking at things like Java threads, Java runnables, the Java executor framework, which are all examples of threading mechanisms and threading frameworks. And then we'll also take a look at a boatload of synchronizers like semaphores and different kinds of locks and monitor objects and so on and so forth. And even though we're using this in Android, everything here generalizes beyond that. In fact, the only reason we're really using Android is so I could have a really cool client app that looks interesting and does fun stuff and actually lets you visually debug your program, because if your program is buggy, the beings won't gaze properly, and you'll be able to see that literally. You'll literally see that it doesn't work, because the beings will just sit there and not do anything, for example, if you don't start your threads, for example. The assignment assessments are done in a somewhat novel way. If you've taken any of my classes before, you're familiar with this. If you haven't, this may be novel, because I don't think anybody else here does it quite this way. So what happens is, when you submit your program initially, I review it and give you comments. And then you fix the comments, you address the comments, and then you resubmit it, and then that's the version that's graded. So you kind of get 2 bites at the apple, if you will. Now, with, having just seen the latest Spider-Man movie over the break, with great power there must be great responsibility, right? So with great feedback there must be responsibility. And one of the great responsibilities you have is you have to submit your initial assignment on time when it's due, or you get no score at all. And moreover, as you see if you read the descriptions here, your assignment actually has to be in reasonably good shape. So don't just submit a bunch of gobbledygook. That's a waste of everybody's time. So you'll get marked off if you do that as well. So make sure that you submit stuff that will compile and be largely complete, or I won't spend time reviewing it or grade it. So you have a responsibility to do your best on the first shot. So what happens then is you submit it, I review it, I give you feedback, you get some time to revise it. That time period largely depends on how well people do. If everybody's doing well, you have like a couple days. If people are really struggling, we'll give you more time. And then when you're done, there's a revision date. All of this, of course, is on the website. The GitHub wiki tells you where the deadlines are. And then you resubmit the program, and then the graders will give you the final grade. Now, you should also know, and we'll talk about this shortly, how well you're going to do on the final grade, because we have unit tests and auto-graded tests that will tell you what you are doing right or wrong. Again, you need to attend class or you lose points on your assignment. Take a look at that here. And of course, as with everything, the work that you do has to be your own. This is not a team's course. This is an individual course, and that principle applies for the quizzes and the programming assignments and the final exam if we have one. So everybody's bound by the same honor code as usual. So as I mentioned, the bulk of your grade will be based on the results of automated unit tests. So there'll be unit tests that run with your program, and when you take a look at the video that shows how to do the assignment and what the assignment's about, it also shows you how to run the unit tests and so on. And these unit tests are cumulative. So every assignment is an extension and enhancement of the one before it. And so you have to make sure that for each new submission, all your old stuff works. So why do we do that? The incentive is to make sure that you take the comments I give you and the grade you get from the final version of a given submission and fix the bugs, and then make sure for the next assignment that you fixed all those bugs. And that's good practice for work in the real world, where you typically don't just leave stuff behind, right? There's a kind of a bad habit we get into in the courses we teach in school, where each thing you do is sort of a dead end. You do an assignment, you walk away from it. You do an assignment, you walk away from it. Very rarely in the real world do you have the luxury of walking away from something you've done. So it's meant as good practice to get used to maintaining and fixing and improving and so on, and making sure things continue to work over time. So you make sure that all the tests pass, and by the time we're done with the final assignment, there'll be 4 assignments, you'll have like 180 tests or something like that have to pass. And make sure you stick with the right version of Gradle and the right version of Android and stuff like that. Otherwise, things can go awry. Here's the preliminary weighting of the courses if we have a final. So 45% is the quizzes, and there'll probably be 6 or 7 quizzes every 2 weeks or so. 40% programming projects, 10% final exam if we have one, and then 5% participation. And the final exam, of course, if we don't have one, we'll just split that between the quizzes and the programming projects. So quizzes will be worth 50%, programming projects will be worth 45%. 5% of participation. Do not squander the participation. This is one of the things that people often don't do, and then they wonder why they don't do as well as they would have hoped. So this includes several things. It includes attending class. It includes being involved, and being involved can be asking questions in class. Being involved can be asking questions on Piazza or responding to things on Piazza. And following directions. So following directions means things like make sure you submit your programs on time, make sure you do a good job with trying to make them work the first time through. And this has an impact on other parts of the scoring, so make sure you read the course material carefully to understand it. If you don't come to class and don't participate and don't follow directions, it's very hard to get an A. So I'm just putting that out ahead of time so that there's no surprises and disappointment later. Let's talk about setting up the environment. So you'll need to get Android Studio. You should get the latest version, which I believe is Arctic Fox 2020.3.1. I don't know why they stuck themselves with 2020. That seems like a bad year. They should have gone with something later. I'm not sure that's any better, but at least 2020 seems like a bad year. So that's the version that you should use. And if you go to this link at the Android site, or if you Google download Android Studio, it'll probably take you to this link. So you'll get that and install it, and it'll prompt you for a bunch of different things. Select the R version. This is the SDK manager, so select version R, which is Android 11, and when you do that, it'll automatically download that stuff, including the version of Java that you need. You'll then need to create an Android emulator, and I think you want to use API 30. So API 30 just corresponds to the version of Android we're using. You could probably use other emulators, but let's try to go with that one because I know it works for sure. And you can pick whatever form factor you want. I think I have a Pixel 4 on my emulator, but you can choose whatever you want. It'll give you a bunch of options. And the main issue there is just sort of the size of the device that shows up in the emulator and maybe the skin, but don't fret about that too much. Just pick one that works. I suspect you can skip this step. In older versions of Android and Android Studio, you had to explicitly go in and turn on this Intel optimization for their hypervisor to be able to use hardware accelerated extensions called Haxum. You don't have to do that anymore, hopefully. And the good news is if this is enabled either by default or manually, your emulator should run a lot faster. The old emulators were dog slow, but the new ones should be a lot better. You'll also have to set up GitLab. And this is a little tricky, and I'll put out a video, but this is just kind of to get you acquainted with this. So what you're going to do is you're going to start by creating your GitLab repo by going here. And you should take a look at this link for information on how to set up an SSH key for GitLab. You'll need that for security purposes. So you'll create your GitLab repo if you don't already have one. You're welcome to reuse what you've got if you already have a GitLab repo. And then you're going to basically make a repo with the following names: CS-254-spring-2022. And you'll create that, and then once that's created, that's the name of the repo that you're going to create at GitLab. Then you're going to go onto your machine, and you're going to clone that repo into your local machine. So you say git clone, git@gitlab.com, whatever your GitLab username is, and then the name of the repository. And that will go ahead and create a directory on your local device, wherever you put it, which will be called CS-254-spring-2022. And then you'll go ahead and change directories into that. So now you're in your working folder. And once you're in your working folder, you're going to follow these steps, and this is described here at this link. You're going to say git remote add skeletons. I think you can call it whatever you want, but just call it skeletons because you're getting skeletons. And then you go to my GitHub repo. So what that's going to do is that's going to go ahead and make a connection in your GitLab repo to my GitLab repo, and then you're going to go ahead and pull the skeletons from that repo. And it may be called main now as opposed to master. Probably I should update that. Master is a legacy term. It should be probably git pull skeletons main. And that'll go ahead and pull the contents of my repository, which will initially just be assignment 1A, into your local workspace. And then you do your work. You edit the files and do whatever you need to do to get the test passing. And I would actually recommend you do the following multiple times. You can commit your changes with git commit -a-m, and you give a message that you want to do to indicate what you just did, like added first implementation or something like that. So you commit your changes. That pushes work from your repository to your local Git repository. So it's now in some common place on your local computer. And then when you're ready to, and I actually recommend doing this a lot too, when you want to make it go back up to the server, to your GitHub repository that's in the cloud somewhere, you say git push origin master or git push origin main, and you push the changes, and that goes from your repository over to your GitLab repository. So now it's in a place where I can get access to it. And so I will then be able to go in when you tell me what your repository name is and add comments to your code. Now your repository should be private. We'll talk about that in a second. So only I or the TAs can see it. And the way you do that is you go to GitLab and you create a new project. And the API may have changed a tiny bit because they change it all the time. And you put the name of the project. This, of course, should be CS254 Spring 2022. And you want it to be a private repository. And once you do that, it'll set it up for you. And then you're going to go ahead and add in a bunch of people as maintainers, which would be myself and the 3 graders. And I sent you my GitLab ID and their GitLab IDs in an email. If you didn't get that, let me know. I'll be happy to repost it. And then at that point, you're pretty much ready to go, and you can go ahead and clone everything on your local machine. One of the great things about using Android and Java, for that matter, is everything's open source, so you can get access to the Android source code by browsing it. You can download the Android source code. You can browse the Java source code. You can download the Java source code. And this is all very helpful. And we'll actually be looking at some of the source code for Java. We might look a little bit of Android source code depending on what we get to, but we'll definitely be looking at a lot of Java source code from the Java concurrency libraries as we go through different lessons. So to wrap up, as with every course, you get out of it what you put into it. No surprise there. Some of the work is hard. If you have a really good programming background, the first assignment will probably be a breeze. Other assignments will probably be a little harder. If you don't have a lot of programming background, you will take longer time to do it. That's okay. That's the whole point of learning. So you shouldn't be expected to walk in and know everything out of the gate. Otherwise, you wouldn't have to be here. Please don't miss the deadlines. Deadlines are very, very, very important. 95% of people make the deadlines, no big deal, and follow directions. There's always a good 5% of people who don't, which causes a lot of consternation. There's a lot of manual effort on the part of me and the course staff in this class. So meeting deadlines helps to make sure we keep things moving ahead in a consistent and timely manner. Make sure you participate in discussions in class and on Piazza. And here's the Piazza page. You should hopefully have been invited to this, so you can see that. And you can feel free to, I'll talk about this in a second, feel free to post stuff either publicly or privately there. If it's a general question, please post it publicly. You can post it anonymously, of course. If it's a question that's, like, why is my code failing and here's my code, please post that privately so that only I see it. There's lots and lots of resources, so we've got lots of office hours. I'll finish uploading the office hour stuff here shortly, but there'll be office hours probably every day of the week. We have the online Piazza forum. There's textbooks, which are suggested. You can do everything here by following the links in the slides and watching the videos, but there'll also be some books you might want to look at. There's tons of links in the PDF versions of the slides, so you don't have to read those things, but they're there to help you. And as I mentioned before, I put all the video lectures online, so you're welcome to take a look at those. Please try to resist the urge to email me directly unless it's confidential. And even then, it's probably going to be more easy if you post it as a private message in Piazza, just so that way I know where to look. I get a lot of email, and I don't want to lose stuff. Whereas Piazza is good about noting when something has been posted without me responding to it, so it's easy to tell when there are questions. It's also, of course, worth noting that investing in this kind of knowledge pays off, and I think we've had computer science has been the #1 highest salary major in the engineering school for quite some time now. I don't expect that to change anytime soon. Maybe if the price of oil goes up enough, chemical engineering will regain the lead. The chemical engineering starting salaries are highly dependent on the price of oil. So I guess that should be no surprise. But with computer science, there's lots of great opportunities. And learning things we're going to learn here, like Git, like modern versions of Java, like Android, concurrency, for sure, synchronization are good ways to differentiate yourself from the rest of the competition out there.